Good morning. Welcome to Unit 2, Lesson 14, Solving Systems by Elimination, Part 1. In today's lesson, we're going to investigate how adding or subtracting equations can help us solve systems of linear equations. We have two learning targets for the day. Number one, I can solve systems of equations by adding or subtracting them to eliminate a variable. Number two, I know that adding or subtracting equations in a system creates a new equation where one of the solutions to this equation is the solution to the system. Our warm-up today is 14.1. It's a notice and wonder titled Hanger Diagrams. So here we have three separate hangers. They want to know what you notice and what you wonder. So go ahead and pause the video, take a couple minutes, and see if there's anything that you notice or any questions that you have about them. Now, if you have a list of things that you noticed and wondered, is there anything that you're wondering now that you might not have thought about before? What do you notice about the left side of the last hanger? So if we look at the left side of the last hanger, notice it has three circles and a green triangle. Notice that the left side of the first two hangers together is three red circles and one green triangle. What do you notice about the right side of the hanger? Well, the right side of the last hanger has one blue square and one yellow pentagon. Notice that the right side of the first two hangers also have one blue square and one yellow pentagon. If we only saw the first two hangers, but knew that the third hanger has the combined weights from the corresponding side of the first two hangers, could we predict whether the weights on the third hanger would balance? Why or why not? So if you think about what we've talked about when we manipulate equations, we always say that if I do something to the left side, I need to do the same thing to the right side so that it remains equal. So if we only saw these first two hangers, and I told you to combine them so that you still had balanced hangers, you probably would have been able to come up with this last one. Because if I start with my first hanger where I have two red circles, and I add a red circle and a green triangle to that left side is going to be heavier and weigh it down. But if I take this yellow pentagon and add it to the blue square, that should even it back out again, because if I added this much weight and it's equal to this much weight, then when I add them together, I expect that the combined hangers would also be equal. So this is a visual representation of what we've been talking about in our equation manipulation. Our first activity today will be activity 14.2, adding equations. Diego is solving this system of equations. Number one, make sense of Diego's work and discuss with a partner. 1A, what did Diego do to solve the system? 1B, is the pair of x and y values that Diego found actually a solution to the system? How do you know? Number 2, does Diego's method work for solving these systems? Be prepared to explain or show your reasoning. Why does adding the equations work for solving the system with 2x plus y equals 4 and x minus y equals 11, but doesn't work for ax plus 11y equals 37 and 8x plus y equals 7? What if we subtract the equations? Would that help us solve the last system? How is adding the two equations here, like and unlike combining the shapes in the two hanger diagrams earlier? How is it different? So pause the video here, get with your partner, and see if you can answer these questions. Okay, let's go through these now. What did Diego do to solve the system? Diego added the bottom equation to the top equation. Because 4x and minus 4x are opposites, the x goes away. Now he has an equation with y only, and he solves for y. Then he substitutes that value of y back into the top equation in order to solve for x. Now Diego knows where these two lines will cross if we were to graph them. Is the pair of x and y values that Diego found actually a solution to the system, and how do you know? Well, if we wanted to prove, then we would just substitute his values into the original equations, and both of them would need to be true. So we would need to be able to say 4 times 1 plus 3 times 2 equals 10. 4 times 1 is 4. 3 times 2 is 6. And 4 plus 6 does equal 10. So the first one works, but it needs to work for both of them. So now we have negative 4 times 1 plus 5 times 2, and that needs to equal 6. Negative 4 times 1 is negative 4, and 5 times 2 is 10, and negative 4 plus 10 does equal 6. So yes, Diego's point pair does solve this system of equations. Does Diego's method work for solving these systems? So, Diego's method was to add these together. So 2x plus x equals 3x. Plus y minus y is 0, so the y's go away. And 4 plus 11 is 15. 3x is multiplication. The opposite of multiplication is division. And if I divide the left side by 3, I must divide the right side by 3. So we get x equals 5. Now I can take this value of x and substitute it back into one of the original equations. I will use the bottom equation. So 5 minus y equals 11. The opposite of 5 is minus 5. And if I subtract 5 from the left, I must subtract 5 from the right. So if negative y equals 6, then y equals negative 6. Now we need to know, do these values actually solve? So we can say 2 times 5 minus 6 equals 4. 2 times 5 is 10. 10 minus 6 is 4. So the top equation is true. Now we try the bottom equation. 5 minus negative 6 becomes 5 plus 6. And 5 plus 6 does equal 11. So Diego's method does work for this system of equations. Now, does Diego's method work for this system of equations? Again, Diego's method is to add the equations together. 8x plus 8x is 16x. 11y plus y is 12y. And 37 plus 7 is 44. So Diego's method does not work for this system of equations because adding them together did not eliminate any variable. So I still have an equation with two variables and no way to solve it. So why does this work for the first system and not the second system? Because in the first system, we had opposite values for y. So when we added them together, it eliminated the y and gave us an equation with only one variable, allowing us to isolate that variable and find a number value for it. In the second system, none of our variables were opposites, so when we added them together, neither one of them got eliminated, and therefore we can't isolate one variable and solve for a numerical value. What if we subtract the equations? Would that help us solve the last system? So if we go back, and instead of addition, we try subtraction, now I would have 8x minus 8x is 0, so my x's go away. 11y minus y becomes 10y, and 37 minus 7 equals 30. The opposite of 10y is division. And if I divide the left by 10, I must divide the right by 10. So y equals 3. Now I can substitute this value for y back into an original equation. So I can say 8x plus 3 equals 7. I need to get rid of plus 3 by subtracting 3 from both sides. So now I have 8x equals 4. Get rid of the 8 by dividing both sides by 8. And I get x equals 1/2. So now I have been able to solve by using subtraction. Because my x variables were the same, I needed to subtract to make one of them go away. How is adding the two equations here like and unlike combining the shapes in the two hanger diagrams? How is it different? So it's the same in that we are adding the two equations, the left side and the right side, like we added the left side and the right side of the hangers. It's different, however, because our objective was to eliminate something from one of the sides by adding. In the hangers, we just added. We didn't eliminate anything. So our next activity is 14.3, adding and subtracting equations to solve systems. Here are three systems of equations you saw earlier. For each system, use graphing technology to graph the original two equations in the system, then identify the coordinates of the solution. Find the sum or difference of the two original equations that would enable the system to be solved. Graph the third equation on the same coordinate plane. Make an observation about the graph. So, first thing they want us to do is use graphing technology. And a tool that we have is desmos.com/calculator. This is a free online graphing calculator that will allow us to do these problems. So in the first system, we have 4x plus 3y equals 10. So we just simply type 4x plus 3y equals 10. So what we're saying here is that every single point pair on this red line makes this equation true. Now we want to graph the bottom equation. Negative 4x plus 5y equals 6. So we click in a new row, and we have negative 4x plus 5y equals 6. And this is showing that every single point pair on the blue line makes the second equation true. They want us to identify the coordinates of the solution. So the solution is the point where they cross. And if you hover over the little gray dot in the middle, it'll tell you the solution is 1, 2. X equals 1, y equals 2. So we can write that here so that we don't forget. 1, 2. So now we want to do system B. So let's try 2x plus y equals 4. So this says every single point pair on this green line makes this equation true. Next, we have x minus y equals 11. X minus y equals 11. So now we're saying every single point on this purple line makes this equation true. So if we want the point that makes these both true, we can hover over the gray dot and we see that our solution is 5, negative 6, where x equals 5 and y equals negative 6. So we can write that solution in here. Find the sum or difference of the two original equations that would enable the system to be solved. So in the first system, because we have opposite x values, we could add these together. If I added them together, I would get 8y equals 16. That would allow me to find y, substitute it in, and find x. If I look at system B, my y values are opposites, so again, we would want to add. Now, if I have this, I have 3x y minus y is 0. 4 plus 11 is 15. And that would allow us to solve for x, substitute it back in, and solve for y. Number 3, graph the third equation on the same coordinate plane. Make an observation about the graph. So now we would have 8x plus 11y equals 37. Get a new line here. 8x plus 11y equals 37. So this is the black line. Every single point on the black line makes that top equation true. And then we have 8x plus y equals 7. So now we have this red line. So every single point on this red line makes this equation true. So if we were going to look for the answer, we would be looking for the point where they cross, which would be this point right here, 0.53. So if we look, notice that every time we found a solution, we were looking for the points where they would cross. It says now subtract the equations you previously added, or add the equations you previously subtracted, and then graph the resulting equation on the same coordinate plane. So let's clear this up. So now they want us to try subtracting this one. So if I did subtract 4x plus 3y equals 10, negative 4x plus 5y equals 6, but we're going to subtract it this time. So 4x minus negative 4x becomes 4x plus 4x, so that's 8x. 3y minus 5y would be negative 2y, and 10 minus 6 would be 4. So now if we graphed that, 8x minus 2y equals 4. If we try to graph that on the same coordinate plane that we did the originals, 4x plus 3y equals 10. And then negative 4x plus 5y equals 6. We see that all three of them combine to meet at 1, 2. So even though it doesn't help us solve it mathematically, we can see that we would still end up with the same solution. Here, it allowed us to find it mathematically, and we found out the answers were 1, 2. Even when we subtracted, when we graphed that, we still ended up with a solution at 1, 2. What do we notice about the graphs? We notice that they all still cross at 1, 2. Why do you think the graph of the new equation intersects the other two graphs at the same point? Well, we said we were looking for the solution to the system. So we're looking for the one point where those two cross. By adding them together or subtracting them from each other, we create a new equivalent equation. And remember, equivalent equations are going to have the same solution set. So all we're doing is we're creating new equivalent equations that end up giving us the same solution set as when we combine them. So our lesson synthesis, look at a system that you would have chosen to solve by substitution. Would you still choose to solve it by substitution now? Why or why not? Look at a system that you would not have chosen to solve by substitution. Would it help to solve by elimination? Why or why not? Pause the video for a moment, talk with your partner, and then come back to the video. So this was in our previous lesson on substitution. And when we did that, we said system 1 I would have solved by elimination, and I told you we would talk about that this week. This one I would solve by elimination because my n values are opposite of each other, so I would want to add them together, because then that would give me 5m equals 101. I could solve for m, substitute it in, and then solve for n. System 2, I said I would use substitution because this equation is set up to solve for y, and I can take this value of y and just plug it in right here. That gives me an equation that only has x values. I can isolate x and solve for it, and then substitute it back into the bottom equation, which is set up to solve for y. So this one would use substitution. System 3, I don't have opposite variables, but I do have the same variables. So I could solve this one through subtraction. Now 5x minus 5x is 0. 4y minus 11y is negative 7y. And 15 minus 22 is negative 7. Now I have a single variable equation. Solve for y, substitute that value back in, and solve for x. So we want to be able to look at different systems of equations and understand, would I want to solve this using substitution? Would I want to solve this using addition for elimination? Or would I want to use this for subtraction to get elimination? Our cooldown is 14.4. What to do with this system? Here is a system of linear equations. Which would be a more helpful solution for solving the system? Adding the two equations or subtracting one from the other? Explain your reasoning. Number 2, solve the system without graphing. Show your reasoning. So pause the video for a moment, go on Kidem, See if you can correctly answer these questions. If you can, you should be right on track for our test, which will be on November 3rd. If you still have questions or are unable to correctly answer these, bring those questions to class and get clarification from me. So if we look at these, I notice I have a positive 1/2 y on the top and a negative 1/2 y on the bottom. So if I add these together, then I can get rid of my 1/2 y. Number 2 wants me to actually solve it. So if I add these together, 2x plus 6x is 8x. 1/2 y minus 1/2 y is 0. And 7 plus 5 is 12. 8x is multiplication, so I divide by 8 on both sides, and x equals 3/2 or 1 1/2. Now that I know the x value, I can substitute that back into either of these equations on top. So I could say 2 times 1 1/2 plus 1/2 y equals 7. 2 times 1 1/2 is 3. I get rid of the 3 by subtracting it from both sides. And I get rid of the 1/2 by multiplying both sides by 2. So y equals 8. So my solution is the point pair 1 1/2, 8. This is where the two lines would cross if we graphed them. Our glossary has 4 terms for this lesson. Elimination, a method of solving a system of 2 equations in 2 variables where you add or subtract a multiple of one equation to another in order to get an equation with only one of the variables, thus eliminating the other variable. Solution to a system of equations. A coordinate pair that makes both equations in the system true. On the graph shown of the equations in a system, the solution is the point where the graphs intersect. Substitution. Substitution is replacing a variable with an expression it is equal to. And system of equations, 2 or more equations that represent the constraints in the same situation form a system of equations. So I want to go back to our learning targets for this lesson. Number 1, do you feel that you can solve systems of equations by adding or subtracting them to eliminate a variable? If you do, then you're good to go. Number 2, do you know that adding or subtracting equations in a system creates a new equation where one of the solutions to this equation is the solution to the system? If you are comfortable with both of these learning targets, then you are on track for the test on the 3rd. If not, please bring those questions to class and ask them so I can get you clarification. Thank you for your time.